Hello my dear student friends. Good evening one and all. Now I am going to discuss my previous topic continuation part. In previous lecture I discussed about regarding BST and its definition and representation with examples. Now I am going to continue the topic with operations of binary search tree. Okay, already I introduced that part. We are having different types of operations. Regularly we are using insertion, deletion and traversing. In traversing, in-order traversal, pre-order traversal and post-order traversal. Now I am going to explain insertion. So here I am taking one formal example, that is draw the BST by inserting the following numbers from left to right. These are all the numbers I am taken. According to these numbers I am going to insert the nodes. Here the first value is 11, that treated as a root node. The next number is 6, that is lesser than to 11, that's why we are going to increase or insert the node at left hand side. The next number is 8, that is lesser than to 11, that is root node, and this is greater than to 6, that's why we are going to increase or insert the node at right hand side of this node. The next number is 19, that is greater than to root node, that's why we are going to increase the node at right hand side of root node. The next number is 4, that is lesser than to 11, that is lesser than to 6, that's why we are going to increase at left hand side of this node. The next number is 10, the 10 is lesser than to 11 and greater than to 6 and also greater than to 8, that's why we are going to increase at a right hand side of this node, that is 10. Next number is 5. The 5 is lesser than to 11 and lesser than to 6 and greater than to 4. That's why we are going to increase 5 here. Then the next number is 17. The 17 is greater than to 11 and lesser than to 19. That's why we are going to increase at left hand side of this 19. Then the next number is 43. The 43 is greater than to 11 and greater than to 19. That's why we are going to increase or insert the node at right hand side of this node. That is 43. Next, the number is 49. This is greater than to this number and greater than to this number and also greater than to this number. That's why we are going to increase the node at right hand side of this node. Then the next number is 31. The 31 is greater than to 11 and also greater than to 19 and also greater than to 17. That's why we are going to increase the node at here, that is 31. This is the binary search tree. According to our previous example, we are going to insert the nodes. How we are going to insert the nodes according to given formal example. So here we are having different types of subtrees in this graph. Here we are having two subtrees. This is the left subtree and this is the right subtree. Okay, according to our definition of binary search tree, the left hand side of the any node is lesser than to the root node. The right hand side of any node is greater than to the root node. So according to this is the insertion of the numbers according to our definition, that is called insertion. So now we are going to discuss about deletion of the nodes. So how to delete the nodes from the binary search tree. So that is the definition of deletion. So we are going to perform the deletion operation in 3 different ways. Anyway, we have to choose, but we are having 3 different ways. So according to the logic of binary search tree, any tree contain at most 2 nodes. At most 2 nodes is nothing but 0 node or 1 node or 2 node. That is the meaning of at most 2 nodes. Here we want to delete the nodes from this BST. We have to choose 3 things. The first one is choose 0 node, 0 node, or choose 1 node, 1 node, or choose 2 nodes. Choose 0 node or choose 1 node or choose 2 nodes. Means a node does not contain any chain. A node just contain 1 chain. A node having 2 chain, either left or right. That is the meaning of this logic. So in this, according to our binary BST, so we have to observe this tree. Suppose we consider this node. This node doesn't have any chain. This node doesn't have any chain. That's why we want to delete this node. We have to delete this node from the graph. So without any updations, just we want to delete. We have to delete this node from this graph because it doesn't have any chain. So suppose we want to delete the node by choosing this option. This is a node contain 1 chain. Suppose we have to observe this node. This node contain 1 chain. So we want to delete this node. So we have to delete this node from this graph. Delete from this graph. So that like this we are going to delete the things. Suppose we are going to delete this node 11. So this is the root node. This node contains 2 childrens, left children and right children. That is this logic. So we want to delete this root node 11. So now we are going to choose the 2 children's logic. But the 2 children's logic is going to be also again depends upon 2 internal concepts. One is in-order preprocessor and in-order successor. In-order preprocessor and in-order successor. So in-order preprocessor means, suppose we want to delete this node or 11. We are using the 2 children logic. It's also contain 2 things. We have to follow 2 things, either in-order successor and in-order posterior. So suppose in-order posterior is nothing but, we have to observe this left subtree. From the left subtree, we are choosing the highest node. We are choosing highest node. What is the highest node in the left subtree? 10. 10 is the highest node. So we are going to update this 10 with the root node. So now we are going to delete this node from the left subtree. Okay, this is the resultant graph when we are following 2 children by using in-order preprocessor. Suppose we are going to use in-order successor. For example, in-order successor. For example, we are going to delete the root node. We want to delete this. we are using this in-order successor. So in-order successor means we are choosing the least node from the right subtree. We are choosing least node or less node from the right subtree. What is the less node we are having? 17 we are having the less node. So we are going to delete this node. So suppose here we are updating 17, then we are going to delete this node. Now we are going to update this 31 here. So now we have to insert the 31 like here also according to that logic, that is greater than to this one, this is lesser than to 33 according to. This is the resultant tree of deletion of binary search tree by choosing the two childrens by following in order successor and by following in order posterior. For example, we have to consider in order means we are sorting the elements in ascending order. For example, suppose according to this binary search tree, what is the in order position? First we have to according to ascending order. So we have to take 4, then 5, then 6, then 8, then 10, then 11, then 17, then 19, then 31, 43 and 49. So this is the in order of BST. So what is the deletion of DST? By choosing the two nodes, we have to choose two things: in order preprocessor and in order successor. So what is in order successor? So this is the 11. This is our root node actually. In order successor means after that node or after that number. What is the after that number? 17. So 17 is going to update in this root node. Then the node will be deleted here according to that. So what is the in order precedence? That is the before that node. What is the before that node? 10. So this is the already we have learned. So according to that, in a deletion of left subtree which is having the highest number. So this is after node, there is a in order successor. Before that node, that is a in order precedence. So this is a deletion of BST. So hope you all understood the insertion, how we are going to insert the nodes and how we are going to delete the nodes. So let us know, we are going to learn. So what is traversal? So traversal is nothing but each and every node we can touch at once in a particular tree. That is called traversal. So we are going to traversal the BST by using in order, preorder, postorder. So already we discussed in binary tree. So these are all things. So according to this BST, how we are going to perform in order traversal, postorder traversal and preorder traversal. So now we are taking a small example. The root node is 30. That is this is 40. This is 10. This is 25. This is 35. And this is 60. For example, we will start with a small example. So this is a BST. So the left subtree, this is left subtree. And this is right subtree. So consider the left subtree. All nodes of left subtree is lesser than to the root node, and all nodes of the right subtree is greater than to the root node. Now fine. So how to perform in-order traversal? In-order traversal. So in-order traversal means, already we discussed how to define in-order traversal. We want to define the tree by using in-order traversal. We need to follow 3 points. First one, left, root, right. Left, root, right. So what is the meaning of left, root, right? So left means not left child. Left is nothing but left subtree. Then we can process root. Then we can process right subtree. So that is the meaning of left, root, right. So what is the left? First we can process or we can access left subtree. Then we can process root node. Then we can process the right subtree. So, and according to this, we are going to write the in order of the particular BST. So, take this BST. So, in these two subtrees, left and right. So, what is left? First, we can perform the left subtree according to in order. So, left, root, right. So, what is left? Left is nothing but 10. So, what is root? Root is nothing but 20. What is right? Right is nothing but 25. So, what is this is, we can apply this left, root, right on this particular subtree. So, again root. So, what is the root? Root is 30. Then we can perform the in order on right subtree. So, what is the right subtree? This is right subtree. So, what is the in order logic? Left, root, right. So, left means what, ma? 35. What is root? Root is 40. What is right? This is 60. So, this is the in order traversal of BST. Are you understood? So, this is in order is nothing but according to ascending order. Already we discussed in the above point. So, that is 10, 20, 25, 30, 35, 40, 60. So, now we can observe this. Next. Next, we are going to perform pre-order. Pre-order. So, how to define the pre-order? Or remember now? So, that is root, left, right. Root, left, right. That is pre-order. So, first we can process root. Then we can process left subtree according to preorder. Then we can process right subtree according to preorder. So, what is the root? Root is 30. So, what is left? This is left. Here we are having the left subtree. We can apply the definition of preorder again in left subtree. So, what is left subtree? This is left subtree. So, now we can perform root. What is root? 20. So what is left? 10. What is right? 25. Again, then we are going to apply on right subtree in preorder. So what is that? Root. What is root? 40. What is left? 35. What is right? 60. So this is the preorder traversal of BST according to given example. 30, 20, 10, 25, 40, 35, 60. Are you understood? Again we are going to discuss about post order. Post order. So what is, how to define the post order traversal? So left root, left right root. Post order. Okay, left right root. Left means we can perform post order on left subtree. Then we can process root. Then we can process right subtree according to the definition of post order. So that is left. Left means what, ma? This is left subtree. In this left subtree, what is left? 10. What is right? 25. What is root? 20. Okay. Again, we are going to perform on right subtree. So what is the right subtree? This is the right subtree. Again, we can apply the post order on right subtree. What is that? Left. Left is 35. What is right? Right is 60. What is root? Root is 40. Then we can process root. What is the root? Root is 30. So this is the post order traversal. So 10, 25, 20, 35, 60, 40, 30. Hope you friends are you understood how to perform the in-order traversal, pre-order traversal and post-order traversal. So again we are taken another example, our previous example. So what is that? So now we are going to try according to this example or according to this BST how to find out in order, pre-order and post order. So this is exercise for you. My dear students, hope you all understood this lecture. Now I am going to complete the BST according to the declaration part. So algorithms already we discussed in BST. So now we have to try how to write the algorithm with the syntaxes according to this explanation as well as like binary trees. Okay. Now today we are discussed how to insert the nodes and how to delete the nodes from the existing BST, how to perform the traversing by using in-order, pre-order, post-order traversing along with examples. Hope you are all understood this lecture. You have to prepare the note according to our class note. Thank you one and all.